All right, guys, we are going to be talking about section 11.1, which is the fundamental counting principle. We're going to be talking about specifically objective 1, which is the fundamental counting principle. We're going to use it to determine the number of possible outcomes in a given solution or situation. Sorry. All right, let's suppose we have a certain number of items, M, right here, group of M items, and we have a second item, and we have N of those. So the total number of possibilities is M times N. This will make more sense when we look at this diagram right here. So this gentleman has two different pairs of pants. We've got blue and brown. And if he chooses a blue pair of pants, then he can have this shirt, or so cream or yellow or blue. And if he chooses the brown pair of pants, he could also have cream, yellow, or blue. So if you count up the number of outfits, 1, 2, 3, 4, 5, 6, you see that if you take 2, 1, 2, and multiply it times 3, 1, 2, 3, you end up with 6 possible outfits. All right. Okay, let's do an example. The Greasy Spoon restaurant offers 6 appetizers and 14 main courses. Okay, so we have appetizers, and there are 6 different appetizers that we can choose from. And there are main courses, and there's 14 different possible main courses that we can choose from. In order to figure out the number of 2-course meals, we are going to multiply those two numbers together. And because I am without a calculator at the moment, I am going to do it the lazy way and click next. And we have 84 different 2-course meals. So you take the 6 and the 14 and you multiply them together, you get 84 different meals. You can extend this idea with more than 2 different groups. You can do it with 3 groups, 4 groups, 5 groups, whatever. In this particular example, this, by the way, this, I don't know if I said, this right here is called a tree diagram. So now we have shoes that we are adding to the mix. We have 2 different pairs of shoes. So we would multiply the 2 pairs of pants times the 3 shirts times the 2 shoes and end up with 1, 2, oops, let's try this again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12 different outfits. Again, you are multiplying these choices together. All right. Next semester, you're planning to take 3 courses, a math course, an English course, and humanities. So math, English, and humanities. Okay. So we're going to figure out how many choices of math, how many choices for English, and how many choices for humanities. So there are 8 sections of math, 8 sections times 5 sections of English times 4 sections of humanities. We multiply that out, and we have 160 different possible schedules. All right, let's take a look at this. Now we have a multiple choice test. Be really careful on this problem. I love to give this question on the test. It has 10 different questions. So we've got question 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 different questions. Each question has 4 answers. So we've got 4 answers for the first question. 4, 4, 4, 4, 4, 4, 4, and 4. So in order to figure out the total number of ways you can answer these questions, you would multiply all of these together. There is a shortcut for multiplication, repeated multiplication, that is exponents. Notice we have 10 of these. Again, I'm going to go to the next slide to see what the actual number is. But one thing that I've noticed when students do this question on the test, they always multiply 4 times 10 and get 40, which is incorrect. So it's 4 to the 10th power, which is a lot of different ways we can answer these 10 questions. All right, telephone numbers. So telephone numbers, we've got the 3-digit area code, and then the 723. So that's our area code, and our 7123, a 7-digit local number. And it says the area code cannot begin with a 0 or a 1, but it can begin with a 2 or a 3 or a 4 or a 5 or 6 or 7 or an 8 or 9. So there are 8 different choices that we can start our area code with. And then it didn't say anything about the next 2 numbers for our area code. So we have 10 single-digit numbers and 10 single-digit numbers. And then it also said the local number also cannot begin with a 0 or 1. So now we have 8 choices to begin our local number, and then 10 single-digit numbers. And we are going to multiply all of these numbers together. Multiply, multiply, multiply. And let's see how many different telephone numbers. That is an awful lot of telephone numbers. All right, there you go.